Hi, my name is Stuart Williams and I'm a Magenic. Today I wanted to do a video on the kind of applications that you can deploy on Pivotal Cloud Foundry and to talk about what we call stacks, the different application technologies that you can get to run on Pivotal. This isn't going to cover Pivotal architecture. There's a ton of really great Cloud Foundry presentations out on YouTube. There's a ton of really super good documentation on the Pivotal website and other places. And instead, I wanted to sort of give business and technology folks an idea of the types of applications and technologies that you can deploy on Pivotal Cloud Foundry. The key takeaway that I want to leave you with is that PCF is a container system. It's just a really great container system. And so if your app would not or should not run on Docker or Kubernetes or some other container system, it's probably not going to be suitable for PCF. So things that really run well in containers are things like websites and web services, batch operations, and kind of anything headless, a job, a processing node, whatever. Those things are great. And all those things have in common is they all, if they're written properly, live behind a load balancer and are capable of horizontal scaling, right? In a perfect universe, things capable of horizontal scaling are things that live well in containers. The other thing that lives well in containers are things that are stateless. So if you're a fan like we are of the 12-factor app, you know that one of the keys is to treat things like that are stateful, like databases and storage and other things, as services. And out in the universe, when we deliver apps for customers, we put those stateful things in the morally equivalent high availability group for that. So if we're up in Azure, then we'll use SQL Platform as a Service or Postgre Platform as a Service. Or if we've got a Mongo, we'll put it on Cosmos DB. We'll use cloud storage up on Amazon. We'll use the equivalent things. On Google, we'll use the equivalent things. If you're running in the private cloud, then, you'd want to stand up anything that is about persistence in its own kind of high availability thing. And then, your apps that are running in containers like PCF can call those. So let's get a high level overview of sort of what the quote stacks look like. At the bottom of the well, at the top of the drawing, is the Pivotal Cloud Runtime. And again, you can go see the architecture of this in any number of places, but that is the orchestrator tier, the host tier that's going to run our containers. PCF offers a huge amount of high availability and other features. Orthogonally to that is a whole bunch of different modules that you can plug into your solution that cover configuration and things like Redis and Hystrix and authorization and connectors to databases and so on that act well in the Pivotal universe. And facading those things are Pivotal Cloud Foundry libraries or Cloud Foundry libraries that are open source that people have written for different languages. So there's one for Java, there's one for .NET, there's one for Node. And these clients can be integrated into your code to take your applications and make them run better, because they'll be able to communicate and leverage the advantages that Pivotal Cloud Foundry offers above and beyond those offered by a container orchestrator like Kubernetes. So while you can deploy your code, your runtime, your languages, your frameworks, your libraries, all that good stuff, and using something called a build pack, which is what takes all of those artifacts and creates a container image that will run in PCF called a droplet. You can do those things directly depending on the technology you're using and which Pivotal features that you want to leverage. You may be able to do that without adding any of the Cloud Foundry libraries to your solution, and you'll get all of a bunch of the other benefits of running in the Pivotal runtime. So fundamentally, the stack is the green box, and that is your choice of runtime in many cases, there's multiple programming languages or package managers that are all part of that ecosystem. And then there's, libraries, frameworks, and packages that add functionality to your code. And most of the time, if your code would run well in a container, it will run well in the Pivotal universe. Most of the semi-scripty languages, so Node.js, Go, PHP, Ruby, Python, etc. And in the diagram, we're showing kind of what the Node universe looks like, but it's not dissimilar for Go, PHP, Ruby, Python, and so on. You can deploy something to Pivotal Cloud Runtime if somebody's built a build pack for it, and there's a huge library of build packs. Some of them are supported by the Cloud Foundry Foundation, others are enhanced and supported by Pivotal Cloud Foundry, and then there are open source contributions where people have built build packs for specific scenarios. So in Node, sort of the runtime, so to speak, is the Node.js engine, right? So it's Node space, the starting point for your app, starts your app up. And the fundamental programming language is the Node version of JavaScript. The package manager is NPM. And it's rare indeed that a Node.js app doesn't have one or more NPM packages added to it. And then there is an NPM package specifically to support all those beautiful Pivotal functionality pieces. And there is a Node build pack that allows you to take your Node app and turn it into a container, a droplet, and then deploy that onto the Pivotal Cloud Runtime. So that's an example of a simple stack. And again, sort of this example works for Node, Go, PHP, Ruby, Python, a whole bunch of different things. There's probably a dozen or so. So then there is the original kind of target for PCF, and it's Java, right? So JVM is the runtime, Java is the programming language, ton of Java frameworks, but the two that really have traction in the Pivotal universe are Spring or better yet, Spring Boot. And Spring Boot is nice because it has the expressiveness of Spring in building especially websites and web services, but it works by convention. So the goal of Spring Boot was to write less Java to accomplish the same thing. And for those of you who have done both Spring Boot, ASP.NET Core, MVC, they have a certain feeling in common. They're by convention. And again, you can push those apps, through the Java build pack, create a Java droplet, and deploy instances of that container onto the runtime. But again, it's better if you leverage some of the functionality that's in the PCL libraries. Here's the .NET Core universe. So .NET Core is for sure the happiest path for .NET developers who want to deploy workloads on the PCF for a couple of reasons. One is that .NET Core's languages and outputs compile to native, and we can target the Linux cells, which are sort of the default cells in the Pivotal Cloud Runtime. .NET Core apps, when they're compiled, will then be able to run as a regular container in the Pivotal Cloud Runtime on Linux, so you get really high densities, and fundamentally their behavior is the same. There's just this additional compilation step that's actually .NET Publish, and then the publish target. The PCF library for .NET has a super cool code name called SteelToe, but it's just the same clients as for the other languages. You can run .NET CLR apps, but there's a couple of gotchas. For one thing, the .NET CLR only runs on Windows, and it doesn't run on just any Windows. It wants to run on Windows with capabilities. Right now, today, as of the moment of making the Windows runtime that is deployable into PCF is Windows Server 2012 R2. And I'll caveat that by saying that may change very rapidly in 2018. And, so you should keep an eye out for announcements. The other thing is that the minimum SKU that it runs on is Server Core plus some stuff added. So there's a licensing and costing component that goes with that. And the other thing is that developers who are writing things targeting for the CLR may be, through no fault of their own, doing things that may not be very container friendly. Remember, Pivotal is a container framework. So if you're doing things that would break immutability of the container, then doing local file I/O or requiring specific hardware like the GPU, or you need to consume low-level Windows APIs, or any number of things that you could do will make .NET CLR apps not really run the same way that all of the other languages run. For one thing, you need a runtime host, a Windows runtime host. And the other thing is they really can't run in a container. They run in something called a process host, and you can go read all about that. But what it means to you, if you are a .NET shop with a big hunk of CLR apps, that you need to go through some evaluation and see whether or not those apps do anything that may not be super friendly in a containerized universe. And if you've tried to containerize the app, like under Docker, and then deploy that onto Kubernetes or some other orchestrator, and you've had unhappiness, the chances are that you're going to have to do some modernization or even migration from .NET CLR to .NET Core to get those things to run the way you want. But CLR apps will run in the Pivotal Cloud runtime. You're just not going to get the kind of densities you'd get because they can't run as a containerized instance.